Okay, we are back and better than ever. Today we are talking about the magnitude of a vector. And just a reminder, the magnitude of a vector is its size, its length, its measure. Um, so we use the magnitude of the vector to figure out the force of the vector, amongst other things. Could be speed, could be length. It just depends on the situation. So let's think about the vector v being equal to 2, 3, that, or 2I plus 3j. So that's 2 units in the horizontal direction followed by 3 units in the vertical direction. Okay, well, what does that look like? Well, um, if I went 2 units in the horizontal direction and 3 units in the vertical direction, then that's my resulting vector. And looky looky, a right triangle is formed. Okay. Well, if these are drawn to scale and represent forces like maybe 2 newtons and 3 newtons, and they're drawn exactly correct, then the length of the vector here is the magnitude of the vector. Length or measure is the magnitude. So it's very simple, a very simple and easy formula, and that is by the Pythagorean theorem. The magnitude of a vector of length v, or length of the vector v, is represented by this symbol here. I think we talked about before how it looks like absolute value. How do we know it's not absolute value? Because we're talking about vectors. That's how we know. So the magnitude of v squared equals 2 squared plus 3 squared equals 4 plus 9 equals 13. Therefore, the magnitude of v is a square root of 13 units. Okay, so it's very simple and leads to a very simple formula. There's the one in the book right here. If the vector has components v1, v2, or that's component form, and this is unit vector form, then the magnitude of the vector is the square root of the sum of each component squared. And here it is on your formula sheet with one additional member, v3. That's when we talk about three-dimensional vectors. So you can still use this formula knowing that in 2 dimensions you only deal with v1 and v2. And v3 doesn't exist, so in 2 dimensions you just ignore that when you use that formula from your formula sheet. So it's very simple. If p equals 3 negative 5 and q equals 2I minus 5j, find magnitude of p and magnitude of q. So magnitude of p, using my formula here, equals the horizontal component squared. Well, first I got to do the square root. So that's going to be 3 squared plus the vertical component squared. So that's negative 5 squared. So magnitude p equals square root of 9 plus 25, and I believe that is the square root of 34. So mag p equals 34. No different here. My components are 2 and negative 5. We're just in unit vector form. So magnitude of q is equal to the square root of 2 squared plus negative 5 squared. So that's the square root of 4 plus 25, or root 29. So the magnitude of vector q, I should have vector signs over these, is equal to q is the square root of 29, and vector p is square root of 34. Okay. We already talked about unit vectors, yes, with I equal to 1, 0, and j equal to 1, 0, and they're the base unit vectors in the positive x and y directions, respectively. So the magnitude, let's think about this, of the unit vector I is equal to the magnitude of unit vector j. That's always going to be equal to 1, because the square root of 1 squared is 1. 1 squared plus 0 squared, 0 squared plus 1 squared. So let's say that we have a unit vector, but we're not sure what this component is, and we need to find k. Well, if we, here's my formula for magnitude again if I get stuck. Let's call this unit vector u. Okay. Well, we know that the magnitude of any unit vector is equal to 1. So therefore, 1 must be equal to the square root of negative 1/3 squared plus k squared. So 1 would equal the square root of 1/9 plus k squared. Okay. So now we're going to we're going to square both sides. Yes. So let's see. 1 is going to equal 1 squared is 1. 1/9 plus k squared. Subtracting from both sides, I get 8/9 equals k squared. And so k could be plus or minus the square root of 8/9. And if I simplify that, then I would get plus or minus root 8/3 equal to k. And it could be plus or minus because we would still have a magnitude of 1. Okay, that is it for finding the magnitude of a vector. See you next time. Becker is out!